If you get an electric shock, do you really think that the safety switch at home will always protect you? The truth is, in some cases of earth leakage, the breaker won't trip, and what happens next can be life-threatening. In this video, we will explain how earth leakage actually happens, why it's so dangerous, and what practical steps you can take, like RCD devices and earthing system, to protect yourself and your home from any electric shock. Consider subscribing to Electrical Engineering Planet channel to support our community. Also, don't forget to share, like, and let knowledge enlighten your world. Let's see this example to understand exactly what is happening. Here, as you can see, we have our power source, line, and neutral. Let's say that, for example, this power source is 220 volt. And we have here a circuit breaker, miniature circuit breaker. And also we have the load, which is a heater. We are converting electrical energy to heating energy. And this is the outer body of the heater, which is isolated, well isolated. And this beautiful guy is touching this body of the heater. There is no problem because this body is well isolated, so there is no voltage here. Here, this circuit breaker, as you know, we are using it to connect and disconnect our circuit, isolate our circuit. Also, this is considered as a protection against overcurrent and short circuit. We have here C and 20 ampere. C is the tripping curve and 20 ampere is the full load or rated current. When the current exceeds 20 ampere, this is considered as overcurrent and the circuit breaker will trip after a time according to tripping curve C. But let's say that the current now is 100 ampere. This means that the current is much over than the rated current, which is considered as a short circuit, and this circuit breaker will trip instantaneously. Let's see exactly what will happen. Let's say that the circuit breaker now is closed. So there will be a closed loop circuit. So there will be a current here will supply power to the heater. Let's say that the current is equal to 15 ampere. So I will call it I heater, IH, will equal to 15 ampere. So the current will support power to this heater to convert electrical energy into heating energy. Now let's say that there is a problem in the insulation happens inside this coil. Now this winding is touching the body, the outer body. This is a very big problem actually. This means that this outer body has a potential now, or voltage. This potential is equal to 220 volt. So now we have here 220 volt. And this guy is touching this outer body, so his hand now has a potential of 220 volt. His leg is touching the ground, so it has a potential of what? 0 volt. Now there is a problem. This human has a resistance and his body is a good conductor actually. Let's say that his body is wet and this resistance is 500 ohm. As you can see, this poor guy now has been electrocuted. How much current will pass? According to Ohm's law, V equal I times R. So I, which is the current of his body, I will call it IB, equal to voltage difference on his body over the resistance of his body. The voltage difference is 220 volt minus 0, so it's 220 volt over 500 ohm, which is his resistance between his hand and his leg. So the current is equal to what? 0.44 ampere. Or we can call it 440 milliampere. So you will say milliampere is very low current, low amount of current. Actually, this is too much for your body because you have here heart and cardiac system, and you have muscles and a lot of things. And this is so dangerous to have this amount of current. Let's see this table. This table illustrates how much current can pass through your body and what will this current do. If the current is 1 milliampere, this is not considered as a problem. If it's 5 milliampere, this is a slight shock felt. If it's 6 milliampere to 16 milliampere, painful shock and begin to lose muscle control. If it's 17 or up to 99 milliampere, this is extreme pain, respiratory arrest, severe muscle contraction. Over 100 milliampere up to 2000 milliampere, and this is the big problem, and this is our case now. We are 440 milliampere. This is a problem and will lead to death. If it's more than 2000 milliampere, this is a sure death. Of course, time is considered as factor. If the time increases, this will cause more problems. So let's get back here. Of course, now you will say that this circuit breaker will come and protect me. I'm sorry, this will not happen. Because now there is a new current here. This current, I will call it I total. I total is equal to what? Is equal to the current that will pass to the heater plus the current will pass through the body. So here this is I total will pass, and some of the current will go to the heater and the other current will go to the body of the heater and will pass through my body. So now here we have the total current equal to I heater plus I body. I heater is 15 ampere and the current of the body is 0.44. So the total current now is 15.44 ampere. And as you know, this circuit breaker is 20 ampere rated current. So it will see 15.44 ampere as a normal current. There is no problem actually. It's up to 20 ampere. So this value is good. But I am shocking now and I am having electricity in my body. This circuit breaker will not consider this as a problem because it sees the current if it's more or less than this amount of current. So what will happen now? This is a sure death. Now we have to see how to solve this problem. This actually is a modification in our circuit with a new device called RCD, or Residual Current Device. This residual current device is an earth leakage device. Let's see what will happen now. As you can see, this is a toroidal iron core. And as you know, the iron is a good magnetic conductor. It's good at conducting magnetic fields. And here, as you can see, the current that will go to the heater, we will pass it as a coil around this toroidal core. And the current that will get back from the heater, we will use it as another coil into the toroidal core and return back to the neutral. So if we are now closing our circuit breaker and we are closing this breaker of this RCD, now the current in the normal condition is equal to 15 ampere, which is the current of the heater. So the 15 ampere will pass through this coil and go to the heater and will return back here as 15 ampere also, and will move into this toroidal iron core and will go back to the neutral. Now, as you know, when you have a coil around an iron core, this will cause a magnetic field to be produced inside this iron core. Let's call it phi 1. This is the flux 1. And here, by returning this amount of current inside this iron core, will cause a new flux called phi 2 and in the opposite direction of phi 1. So now we have two amounts of fluxes, phi 1 and phi 2. So phi total is equal to what? Phi 1 minus phi 2. Here, as you can see, phi 1 is equal to phi 2. So this phi total is equal to 0. There is no flux, no magnetic field here. And as you can see here, we have a tripping coil. This tripping coil is activated when we have a phi total value. If it's 0, there will not be here an activation for this tripping coil. But if phi total has a value, it will send a signal to trip this circuit breaker. Let's see now our example. Here, if there is a leakage that will come to my body, so we have to change this current. The current now is equal to what? It's equal to 15.44 ampere. And it will go 0.44 to my body, and 15 ampere will go to the heater and will return back here as 15 ampere. So now, as you can see, phi 1 is according to 15.44, but phi 2 is according to 15 ampere only. So phi 1 minus phi 2 will not equal to 0. It will has a value now. So this tripping coil will be activated and will cause this circuit breaker to be open, to be tripped. So we have now rescued this poor guy, because we have opened the circuit. And if you come again and started to close this circuit, it will be opened. The second method is earthing system. You have to get an earthing system and earthing rods inside your house to protect yourself from earth leakage. So you will have an earthing rod and you will connect it to all the metallic bodies inside your house. When there is an earth leakage current, it will see two different roads. The first path is your body, and the second path is going to the earthing system. Here, this is considered as 0 ohm, and your body is 500 ohm. Now the current, according to current divider rule, will choose the easy path, 0 ohm path. Actually, this is like an analogy. If we have this 0 ohm and this 500 ohm, let's see two roads. One highway road, which is beautiful and very clean, has no problems, has no bumps, and the other road is narrow and has a lot of bumps and have a lot of problems. So which road you will choose to drive in? Of course, I will choose to drive in this 0 ohm road. And the same for the current. The current will choose the easiest path. So no current will pass here through your body and you will be in a good condition. But the better way to protect yourself is using the two systems together, RCD and earthing system. So earthing system will protect you from having any electric shock, and the RCD will trip the circuit if there is any earth leakage current. In the next video, we will understand that RCD has two different types of breakers, RCCB and RCBO, and we will know the difference between them. Consider subscribing to Electrical Engineering Planet channel to support our community. Also, don't forget to share, like, and let knowledge enlighten your world. Thanks for watching.